So, what does it really mean to be a genius? Is it about going deeper than anyone else in one subject? Or is it about having this insane ability across tons of different fields? Well, today we're going to talk about a mind that just completely shatters that whole question. John von Neumann. Okay, just let that sink in for a second. When a guy who has a Nobel Prize looks at his colleague and wonders out loud if he's basically a new, superior species, you know we're talking about someone on a whole other level. So let's dive in and try to understand the brain that could inspire that kind of awe. Here's how we're going to break it down. We'll start with his unbelievable childhood, then get into how he rewrote the rulebook for math and physics. After that, we'll see how he literally designed the digital age we're all living in, how he got involved in shaping global conflicts, and finally, we'll look at the ghost in the machine, the legacy he left behind that's still playing out today. All right, first up, a mind without equal. And calling him a prodigy, that's a pretty big understatement. His early life in Budapest was just something else. Just look at this timeline for a minute. At age 8, he was already comfortable with calculus. I mean, at 8, most of us are just trying to memorize multiplication tables, right? By 19, he's not just doing math, he's publishing papers that are redefining parts of it. And then at 22, he grabs a PhD in mathematics while also earning a degree in chemical engineering. At the same time, this isn't just about being smart. It's like his brain was running a completely different operating system. And from that starting point, his life's work just took off like a rocket. A mind like his doesn't just solve the problems everyone else is working on. No, he goes after the very foundations of entire fields, the things that were giving all the other geniuses headaches. You have to realize at this time, mathematics was in real trouble. There was this thing called Russell's paradox, which was like finding a crack in the foundation of a massive skyscraper. The whole thing threatened to come down. So von Neumann steps in. He develops new tools like the axiom of foundation and basically patches the crack. He gave mathematics a solid ground to stand on. And this right here shows his unique superpower. Over in physics, you had two totally different, competing theories about the weirdness of quantum mechanics. They didn't look anything alike. Von Neumann comes along and, with this incredible mathematical elegance, shows that they were actually just two sides of the same coin. He created the language that unified them, a language we still use as the bedrock of quantum mechanics today. And if that wasn't enough, he went even deeper. He came up with something truly mind-bending. The idea that at the quantum level, logic itself works differently. The fundamental rules of reasoning that we take for granted, they just don't apply. It's a completely different reality with a different rulebook, and von Neumann helped write it. So after redesigning reality, what do you do next? Well, if you're von Neumann, you start designing the actual tools and systems that will run the modern world. You turn to strategy, and you turn to computation. He pretty much invented game theory out of thin air. Before him, strategy was all intuition, an art. He turned it into a science. With his minimax theorem, he proved that in any conflict where one person's gain is the other's loss, there was a rational, mathematically optimal way to play. This idea completely revolutionized everything from economics to Cold War military strategy. And then there is this. Seriously, take a good look. What you're seeing is the fundamental blueprint for your phone, your laptop, for almost every single computer on Earth, the von Neumann architecture. His revolutionary idea was to store the instructions, the program, in the same memory as the data. That single concept made computers flexible and universal. We are all living in a world built on this diagram. Okay, to really get a feel for the raw speed of his mind, let's try a puzzle he once gave him. So, two bikes are 20 miles apart. They're heading toward each other, both going 10 miles an hour. A fly, flying at 15 miles an hour, bounces back and forth between them. How far does the fly travel in total before the bikes hit? He gave the right answer, 15 miles, almost instantly. But the really amazing part isn't the answer, it's how he got there. So the guy who asked the puzzle was amazed and said, "Oh, you saw the simple trick." The trick, of course, is that the bikes will crash in exactly 1 hour, so the fly was just flying for 1 hour. But von Neumann just looked back at him and said, "What trick?" He hadn't used the shortcut. In a few seconds, in his head, he had actually calculated the entire infinite series of the fly's journey. That's the difference between being clever and being von Neumann. So when you have that kind of processing power, both in your head and in the computers you're helping create, it's inevitable that you'll get called on to solve the most difficult and dangerous problems the world is facing. During World War II, he was a key player on the Manhattan Project. The plutonium bomb, the Fat Man design, had this
Huge problem. You had to crush a sphere of plutonium with perfect symmetry. It was a physics nightmare, and it was von Neumann's math that showed them how to shape the explosives to make it work. After the war, his influence just exploded. He wasn't just a scientist anymore. He became a commissioner of the Atomic Energy Commission. He chaired the Committee for Ballistic Missiles. He was a top advisor on the hydrogen bomb. He was at the absolute center of power, shaping America's entire nuclear strategy. And his advice wasn't just technical. It was driven by a very strong ideology. He described himself as being violently anti-communist and far more militaristic than most. He believed that the only way to ensure freedom's survival was through total technological and military dominance, and that view shaped all of his work during the Cold War. Von Neumann died in 1957, but his ideas were like time capsules. They didn't just endure, they actually became more and more relevant as the decades went on, unlocking new fields and new possibilities long after he was gone. Think about this. Years before scientists even knew what DNA looked like, von Neumann was working on the pure logic of self-replication. He created these abstract, code-based machines that could build perfect copies of themselves. It was pure theory then, but it laid the groundwork for fields like artificial intelligence and biotechnology. He was also one of the first people to see the true power of computers for modeling our world. He created the first computer-based weather forecasting group. And way back in 1955, he was already modeling the effects of CO2 emissions and warning about potential global warming. Over half a century ahead of the curve. So what does this all add up to? It means his fingerprints are everywhere. Quantum computing, our economic models, artificial intelligence, computational science. His thinking is woven into the very DNA of our modern world. It's almost impossible to grasp the full breadth of his impact. So I'll leave you with this final thought. Decades ago, von Neumann looked at the pace of technological change that he himself was fueling, and he predicted a moment, a singularity, where change becomes so fast and so radical that human life as we know it would be transformed forever. It makes you wonder, doesn't it? As the man who designed so much of our world, was he also the first to see how it might end?